Let's solve the level order traversal algorithm using breadth-first search, also known as BFS. Welcome, Java Challenger. By learning the BFS algorithm, you're going to be better prepared for coding interviews. Now let's see the fundamentals and code solution of the level order traversal algorithm using BFS. Okay, so let's explore the breadth-first search algorithm. And we're going to explore BFS within the level order traversal algorithm challenge. So what is the problem statement? So we're going to receive a binary tree and we need to return the level order traversal of its nodes values. Basically, we're going to receive a binary tree of numbers and we have to output all of those levels in this tree, basically. The input is going to be the root of the binary tree. The output will be a list of lists where each sublist contains all the values at a particular depth in the binary tree. And this is the example of a binary tree. So this is the root node. Those connections are also called as edge. This is another node. This is also called as leaf node because, as you can see, this node doesn't have any children. This node has 2 children, which is totally fine. And remember that to be a binary tree, a node can't have more than 2 children. If a node has more than 2 children, then it's not a binary tree. And the constraints are that the number of nodes in the tree will be in the range of 0 to 2000, and the values of the nodes are integers. So now let's go to the fun part. Let's go to the code solution. Okay, Challenger, so let's see the tree node object. So this is the objects that we're going to create our binary tree. As you can see, we have the value of the node. We have the left node and the right node. And here in this constructor is where we put the first root node of our tree. And here is the structure of our binary tree. And I'm going to show you in code how that works. So the number 3 will be the root of our binary tree, which is this one. And we put 9 in the left and 20 in the right node. And from the right node, which is this one, we put on the left 15. And from the right node to the right, we put the number 7. And this one is a bit more complicated, but you understand the idea. I don't need to go over this again. Let's now build the algorithm with the solution. So here we will return a list of a list. And if you're used with a matrix, this is the same as a bidimensional array. So it would be something similar to that. But the difference is that we are doing that with an object instead. So it's a list of a list. It's the same as a bidimensional array. Here we are receiving the root node so that we can do our algorithm. And on this algorithm, we are going to be using the BFS algorithm to traverse into the 3 nodes. So the first thing, we're going to declare our result object. It's a list of a list and a new array list. Then we check if the root is null. And if it's null, we can just return the result. And to do the BFS algorithm, we need a queue. So if you're not used to the queue data structure, remember a real world queue. Remember the concept first in, first out. So when you arrive first on a bank queue, for example, you're going to leave first, right? So remember this concept, first in, first out. This queue will be a 3-node queue, and we can use the data structure linked list. And we're going to add the first element of the 3-node. So basically the offer method will not throw an exception when the queue capacity is full, which gives us the possibility to gracefully handle the edge case scenario when there are too many elements in the queue. So keep that in mind. It's just a small detail, but it's good to know. And if we use the add method instead, the add method would throw an illegal state exception if the element cannot be added due to capacity restrictions. So we're going to be using offer in this case. We could use both, but anyway, doesn't really matter too much for this algorithm. And here we're going to use the BFS algorithm. So while the queue is not empty, we continue. Then we get the level size on each row. So this is the list of each row. And let's continue here. Then we're gonna get the current node. To do that, we use the poll method. And this method retrieves and removes the head of this queue, or returns null if the queue is empty. So let's continue. Then the current level, we add current node dot value, and then we check if the current node dot left is different than null. Current node dot left, and we also check the right side of the node. Basically, if the right side of the node is different than null, we're gonna add the right side of the node in our queue. And then after this looping is over, we're gonna add this list into our result list. And then finally, we're gonna return the result. So as you can see, it's not that complicated. We just need to know how to implement BFS, and then we're gonna be fine. But to fully understand this algorithm, now let's debug the code and see how it works. So here we're gonna get the simple tree, and then we're gonna invoke the level order method, passing the simple tree, and then we're gonna print out the levels here. Okay, so now let's debug our algorithm. So here we have our bidimensional array, and here we're gonna create a linked list. And as you can see, we have all the values from the simple queue, which are here. And you can see that all the objects of the queue are connected by a chain of objects. And here we are dealing with a graph algorithm because a tree is a special type of graph. And here in this while looping, we check if the queue is not empty, continue, and we're gonna get the size of this queue, which is 1. And then from this queue, we will remove the head element, which is value 3. So here we have the value 3, and as you can see in this queue, the size is 0 now, and we're gonna add the value of 3 in this current level. And if the left side is different than null, then we're gonna add here the left side to the queue. The same thing for the right side. So here we have the value of 20. So we are basically here now. Now we continue. So we add the current level here now. The queue still has the size of 2. So we're gonna continue. So we are here now. So let's continue. We're gonna remove the top element of the queue, which is 9. In the current level, we add 9, which is this one. Here the left element is null, and here is also null. So we just continue. And now we have only 20, which is this element. And now we have the left and the right elements here. So let's continue, and we add the value of 20 to the current level. And here the left element is different than null. So we're gonna add the left element to the queue. And here, since we have this element, we're gonna also add this element here. Now we're gonna add our array list to the result. And now we are in the last elements, and we're gonna just add those to the final list. So we have the third level of our binary tree. Now let's return the result. There we go. We have exactly the elements we have here. So we have 3 levels, and that's how we show the output of our binary tree. So now let's check the complex tree. Let's also debug this code. So we are here on the top element. Let's continue. So we're gonna remove that element, number 10. We're going to add it to the current level list. And we have an element on the left, which is 5, and another one that is 20. And we're going to add those elements to the queue. Here we have the element 20. And then we're going to add only the element of 10 to the first level of our queue. And then we're going to continue traversing in the queue from the two elements we have. So we have the element 5 and 20. So those are the elements. The size of our queue is 2. We create a new array list. And then we're going to remove the top element. In this case is 5, which is this element on the left. And we're going to check the left and the right side of it, which will be 3 and 8. So let's continue. We're going to add those elements here. And now we are on the element 20. So we are here. Let's remove this element. Let's add the number 20 to the current level. If the left is different than null, so in this case, it's 15 and 25. So let's do that. 15 was added, and then we see the number 25 here. That's the second level of our binary tree. So we have those elements, 5 and 20, which are those ones. So now we have all of those elements, 3, 8, 15, and 25. Yeah, as you can see, it's number 3, 8, 15, and 25. 3, 8, 15, and 25. Now let's remove the top element. In this case, it's gonna be the number 3 element, which is this one on the left. And then we're gonna check the left elements and the right ones. In the case of the number 3, we only have the left element. Now we're gonna go to this element, number 8. Number 8 only has the right side. Now number 15, we have only the right side. Then we're gonna add to our queue. Now we have the number which is here. It's our last element of the row, and the 25 element has 2 elements here, right? There is the element 22 and 30. So let's see that, 22 and 30. And that's all for this line. So we're gonna add this line of elements in our array of array. And now we are in the last row. So we're gonna get those elements now. And none of them has any left or right child elements. So let's go. The first element is 1. Second one is 9. The third one is 17. The other one, 22. And the last one is 30. And now we're gonna get our result. And as you can see, it's pretty much the same as what we have here. So to recap, the breadth-first search algorithm is extremely important because you might need for a coding interview. And watching the video is great. And if you watched until here, congratulations. But you need to also try out on your own. Try to implement the BFS on your own. Practice coding challenges on LeetCode or HackerRank, because that's the only way to get good with those coding challenges so that you are not too much pressured during a coding interview. And because you're watching until this moment, I'm leaving a special gift to you, which is the Challenger Developer Guide. And I'm leaving the link of the book in the comments of this video. It's totally free. So those are principles that will help you boost your career and go to the next level as a developer. And that's pretty much it, Challenger. I hope you enjoyed, and I'll see you in the next one.